In this problem, it says the following. A wheel has a radius of 0.40 meters and is mounted on a frictionless bearings. Now, a block is suspended from a rope that is wound on the wheel and attached to it. The wheel is released from rest and the block descends 1.5 meters in 2 seconds without any slipping of the rope. Then the tension on the rope during the descent of the block is 20 newtons. 20 newtons is the force. What is the moment of the inertia of the wheel is the question. So first things first, we list all of the known values. The radius, the distance represented as delta y, shown right here. The delta t represented change in time, which they said it was 2 seconds. And the force, as the tension on the rope during the descent of the block is 20 newtons, which is represented right here or right here. Now there is an equation that we can use to find the moment of inertia, which is the torque being equal to the moment of inertia times the angular acceleration. So we can play around with the values step by step so we can find the moment of inertia. So first, now the torque is also represented as tension times radius. So we have one known, which is the 20 newtons. We know the radius, but we don't know the angular acceleration. So the first step is to find the angular acceleration, which is represented as the acceleration divided by the radius. So first we're going to find the acceleration. One way we can find it is with the value given, delta y, the distance. It is represented as 1/2 at squared. As we solve for a, we have 2 times delta y divided by t squared on one side. So as we continue plugging values, we get with 3/4 for the acceleration, or 0.75. Now that we have the acceleration, we can find the angular acceleration. So we could say that 0.25 divided by the radius, which was 0.4, is going to give us 1.87. Now that we have the tension, the radius, and the angular acceleration, we can solve for the moment of inertia. Now the moment of inertia is going to be the tension times the radius divided by the angular acceleration. So as we plug in the values in this case, we end up with an answer of 4.27 kilograms per meter square.